Hello, my name is Julian Campione, and
My name is Yaman, and the reason why we chose this topic is because, well, first of all, it ties in with the physics of waves, which we learned in our course, Waves and Modern Physics. Second of all, is because we want to understand the technology behind the headphones on how it does noise canceling. And to add on, in today's society, there's a lot of noise pollution. So I think understanding how noise cancelling works would give us a deeper appreciation to the physicists that discovered how to do the noise cancellation.
what's going on, guys? Today we're going to be doing a pretty fun experiment about sound interference and destructive waves and how your headphones do it. You might be wondering how we did that. Well, here's the explanation. The two speakers on this Chromebook are 0.2625 meters apart. And for the sound to cancel out, this length has to be half lambda. So lambda is going to end up being 0.525 meters. And since the speed of sound is constant at 20 degrees Celsius, and we have this very nice equation here, we can plug in the values to find out what frequency we need to cancel out the sound, which ends up being 653.3 hertz.
Okay, so the reason why we measured these two speakers at half lambda is because we wanted destructive interference. Destructive interference, what it allows is that basically the two waves, okay, will cancel each other, so then you can't hear anything. But if, for example, we did it at just lambda, it's just going to be constructive, so it's going to be even louder. So we just want to make sure that like the distance between the two speakers have to be half lambda in order for this wave and this wave to cancel out, so it's destructive, you can't hear anything. And if the opposite would be just like basically those two waves, well, the distance would be just one lambda, so those two waves would add up and then it becomes even louder.
So why does the sound only cancel when we become in line with the speakers? This is why. As we can see here, above the speakers, the green sound waves and the black sound waves overlap. The highest pressure points of the black sound wave and the green sound wave are in the same spot. But as we come down, we can see that the peak of the green sound wave and the peak of the black sound wave are not in the same spot. In fact, they're basically perfectly separated. So as we come down, we start to hear this sound instead of the amplified sound over here.
Okay, so this experiment we just showed is about active noise cancelling. So basically what's going on is, imagine yourself, you're listening to a random song, okay? There's outside sounds just going to your headphones and you can hear them. But since, let's just say you have AirPods Pro that have noise cancelling, what it allows is that basically when the outside sounds are going to your headphones, this headphone will detect it, and then basically it will send another sound, but destructively, basically like out of phase. So if it's out of phase, that means those two wavelengths, okay, are gonna cancel each other. So then you won't hear the outside sound, and you're just gonna listen to your music. And this is basically what active noise cancelling is.
Now, just from the nature of wearing headphones, your ear is always going to be in line. You always have your headphones or earphones right on your ear, so you're never going to end up being up here where the sound is constructive and you hear the outside world extra loud. Your ear, when wearing headphones, is always going to be here, and the electronics inside the headphone make it so that these sound waves are always destructively interfering.
Okay, so you're wondering why we did this setup for this experiment, right? Us, we want to make sure that this computer, well, the two speakers in the computer does destructive interference, right? So basically, right now, when like this room is very echoey, right? So us, we want to make sure that like there's no noise when we try to listen to the two speakers doing the destructive interference, right? But since there's too much noise, we can't really make out of it. So we put coats, hoodies, and backpacks here so it doesn't echo as much and the sound waves don't bounce as much. So then when we do the experiment, we can actually effectively make out the destructive interference by, like there's no noise basically. Here's a fun fact about noise cancelling. There are actually two types. One is active, which I just explained to you. The two sound waves basically cancel out. Now we're on to passive. Passive, basically, the outside will emit a sound. Okay, let's just say the outside emits a sound while you're listening to music. And basically this sound is gonna bounce inside your headphones, and they're gonna lose energy as they bounce and reflect everywhere, right? And then after that, they'll come out. Obviously, this is a less effective way to do noise cancelling because there's still sound that's gonna go through your headphones, and you're still gonna hear a bit of the outside, right? Compared to, let's just say, if we did the active noise cancelling basically cancel out the noise, while this one just reflects the noise. All right, now we're gonna do a passive noise cancelling. See how the sounds gets a bit more muffled because basically all the sound waves are just like bouncing everywhere in the coat, and it's just like it's losing energy as it does it, so you can't really hear as much.